Howdy, I'm Joseph Shimizi, Sales Support Engineer for Professional Technologies at Sony. In our first tech tip, we talked about color gamut. This is part 2, where we'll be talking about gamma, which is the other most equally important aspect of our video signal, and knowing about it will help you get the pictures you want. So there are 2 components to a video signal. In part 1, we talked about the color side of the signal, which is our gamut. But now, the equally important part is the black and white portion of our video signal, which is also referred to as our dynamic range and can also be called luminance. Really, how bright does a pixel have to be given the input of the data from a video signal? Hence our luminance. Why do we need to do this? Why not make it simple and say what the camera sees, we take that level, and then we just have that same level coming directly out of our display? One would think that that would make things very simple. Really, the issue is that the light levels we live in are too extreme for our video systems, even as they are now. So while we can record more color than the eye can appreciate, brightness is still a sticky widget. So even in high dynamic range these days, natural light still presents an amount of information way beyond what a camera can capture and monitors can reproduce, at least today. So this is why we need to address this. What we can do is actually compress the luminance of the image by distorting the difference between the light coming into the camera and the data value getting made and coming out. This compression is called a transfer function. But if we compress it coming out of the camera, well, then we have to correct it on the display side, uncompress it so it looks right. So I'm going to get a little geeky here, but bear with me. Here's a graph that we can use to show how this works. On this graph, we'll show light. And here it is. And we can show our video level right here. So now we have a transfer function, which is actually the thing that is gamma, to format the light coming from the camera, and another to format the light to the display. It can be very confusing to just call this gamma because there's a gamma on the camera side and there's a gamma on the display side. But that really isn't specific enough if we want to be technically accurate and make sure we don't mislead ourselves or another professional. So if I say gamma in a conversation, what do I really mean? So to clarify this, especially in today's day with HDR and where we're going, we can call the data out of a camera as scene referred, meaning that the data is generated in relation to the light coming into the camera. And correspondingly, we can call the light coming out of the display as display referred. Makes sense? So we have new terms to make it clear about what we mean. When we want to describe the conversion from scene referred light to our signal, we'll call this an optical electrical transfer function, or OETF. If we're talking about gamma from the display side, then we're describing it as an electrical optical transfer function, or EOTF, the other side of the equation. So if we're talking about this OETF, then it would graph out something like this. And if we were talking about this EOTF, then it would graph out something like this. And if we were to overlay them, it would look like this. The red line being the OETF, our camera, and the blue line being our EOTF, which is the display. To complete the system, we sum these two together, the 2 gammas, and we come up with what's called the OOTF, or optical to optical transfer function, which is shown in green. So this is the light now. This is the meat of it. We're out of the electrical realm. This is the output of the display, which incorporates both the camera and the display processes, the math, how we recorded it, how we affected it via transfer function, and then shows us the image after it's been packed into our video system. And if you've watched our part 1, this is talking about what 709 has to say about contrast as well as color. Now, when you go to set up a camera and a monitor, you'll find that there are numbers used to show what level of gamma to use. These are called mathematically a power function. and it will have a number. So as you find, the camera will have values of under 1, and the monitor will have values of more than 1. And again, this is just because we're 2/2 of a whole here. So why do we care? If we look more closely at the graph, in the camera, if you select a lower gamma number, you'll be stretching out your blacks more and compressing your highlights. This happens for both the camera and the monitor if you do this on the camera side. Now, this isn't bad, but this is what you should expect when choosing a gamma for the camera that is a lower gamma number. So here's our system. I have a camera feeding a monitor. We have several functions to choose from. As I flip through these settings, for a camera, gamma is an aesthetic choice, meaning just a visual one. You can use the standard settings, but you also have several selections to add interest to your shot. This is the S-Log side of our digital cinema family, where we have S-Gamut for the color. So S-Log has to deal with the gamma portion of the equation. For a monitor, we need to look at this a little bit differently, and what we're looking to see is our camera output compared to the values specified in an industry standard. For setting up a monitor, these need to be set for the values that will be whatever your final display format is going to be. So HD, digital cinema are the two big ones. So if you're working on a TV show, the HD appropriate gamma is 2.4, or sometimes it's called in the standards world ITU-R BT 1886. If it's a movie, then you would be setting the power number to 2.6. And if it's an HDR show and the monitor supports HDR, then you would be setting it to either PQ or HLG, which also have corresponding standards numbers. Gamma can be complicated if you aren't familiar with the basics. And really the basics are just knowing each step of the process. All right, light coming into the camera, and the camera side of the math and organization is our scene referred. What's going on in the display, from electricity and math to making light again, that's our display referred. Then we can add them all together and we can get our OOTF, which is accounting for math, light translation in both places, and then that should be our final image as it relates to a standard. So those are all the steps, and believe me, you have to run it through a couple of times to make this second nature. But if you've ever done editing on a cinema display and then shown it on somebody's TV and noticed that the brightness was all over the place, this is because of those gamma numbers, and that's what's going on. So I hope this helped, and if you have more questions, please let us know in the comments section. We'll be happy to dive into this deeper. Please join us for our next tech tip, and I will be seeing you next time. Thanks for watching.